No, 9. Let's do problem number 9. It says the inequality 1 minus x squared all over 2 is less than sine of x over x is less than 1. Okay? This holds when x is measured in radians and x is less than 1. Find the limit of sine of x over x as x approaches 0. So here we can't just plug in 0 because you'll have 0 in the denominator. Now there's a reason they told you that that sine of x is bounded by these two functions. This is a sandwich theorem. So we just do this by sandwich theorem.
I'm so hungry.
Not that kind of sandwich. The function sine of x, is bounded. In other words, this function will always have a lower value than sine of x over x, and 1 will always be greater than sine of x over x. Okay? And so what happens is if we take the limits of both of these functions, in other words, if I look at the lower boundary and I take the limit as x approaches 0 of 1 minus x squared over 2, well, when I plug that in, it's 1 minus 0 squared over 2. 0 squared is 0, divided by 2 is still 0, and if you take 1 and subtract 0 from it, I get 1. Okay? So now, that's the lower boundary. Let's do the upper boundary. The upper boundary is 1. So I'm going to take the limit as x approaches 0 of the constant 1. Where do I plug the x in? I can't. So it's 1. Whenever you take the limit of a constant, the limit is the constant. So since this is 1 and this is 1 and sine of x is in between these two functions, what do you think the limit of sine of x as x approaches 0 is? 1. Now we could verify this. We can verify this graphically too. It's just this proves it, right? So if I come in and I change, if I graph this function, I'm really surprised that you guys.
Sorry.
No, it's okay. I just sometimes as a teacher you think, man, I've explained this. They're doing their homework. They're getting the right answers. But when you put it all together, like, it gets confusing, right? Like, I don't remember what, when you do 2.1 or 2.2, you're doing the same thing for all your homework problems. And on a test, when you put it all together, that's part of the challenge, though, the real ACT too. So if I come in here, or not ACT, the AP exam. If I come in here as I approach 0 from the left, it's at 0.99. As I approach from the right, it's at 0.99. So it seems reasonable that it's going to be 1. So that's the answer.
Oh.
Does that make sense? Before we go any further, does that make sense?
What if one of the numbers is 2? So it's between 1 and 2?
Yeah, this is a two-sided limit, so it has to be the same value coming from both sides.
Oh, so they would both have to be 1 in order.
They'd both have to be 1. So the question that the student asked is like, what if on this side it was 1, and then what if it was like -3, right? Then no, you can't do a two-sided limit because it's not approaching the same value from both sides. So like on our previous problem, let's go back and plug that in. It's a good question. Our previous problem that we did, we had sine of x divided by the absolute value of x, right? Oh, dang it, I did it again with the 2.
Dang it.
Delete. All right. So now when we look at this function, technically, if I come in from negative infinity, in other words, if I go from left to right, it's approaching -7, right? Well, if I did that one-sided limit, I would say the answer is -7. But now if I come from the other side and I come in from positive infinity, okay, now it's approaching 7. So one is -7, one is +7. This does not have a two-sided limit. They have to approach the same value. Okay? They have to approach the same value. There's no ifs, ands, or buts. There's two one-sided limits, but there isn't a two-sided limit. This is a jump discontinuity. It's not removable, right? So there's a link or a correlation between, well, correlation isn't the right word, but like a removable discontinuity has a two-sided limit. So you could think about that from coming at that from the other direction. If I don't have a two-sided limit, then it's not a removable discontinuity, and that's kind of the connection between the two.